Hello and welcome. My name is PaulineFu. I am a professor at George Brown College. My presentation topic, Cultural Historical Ways of Learning, Implications for Mathematics Education. This presentation explores the nature of cognition development in mathematics education, why educators are aware of cultural issues and try to incorporate culturally sensitive pedagogy. Little concern is given to connect mathematics teaching and learning to the cultural practices within communities. I'll try to make connections between culture and cognitive development to culture relevant mathematics education. I will also try to make connection between culture relevant pedagogy with decolonizing mathematics. I will talk 6 points. One is the culture, followed by activities. Then I will talk about learning and development, zone proximal development, culture within mathematics, and finally, decolonizing mathematics. Definition of culture. Culture as man-made part of environment, which including knowledge, belief, art, morals, law, custom, and so on. Like fish in water, we fail to see culture because culture is the media within which we exist. Culture is an adaptive process that accumulates the partial solutions to frequently encountered problems. Culture is a human cognitive process that takes place both inside and outside the mind of people. Activity theory is an integrated account of mind in action, emphasizes human actions take place within social culture contexts. Take mathematics learning, for example. We have mediated artifacts, that is the mathematics concept and techniques. The subject include students and the teacher. Object could be textbook, desk, online Zoom meeting. Rule refer to classroom rules of norms and regulations. Division of labor could be the group work. Community is the learning and teaching community. Learning and cognition. Learning and doing mathematics is a science-making where culture and cognition is embedded in the process of knowing. Individuals' participation in cultural communities through cultural regularities and variations. In cultural historical approach, learning is conceived as a process occurring within ongoing activities, not divided into separate characteristics of individuals and context. Tools and signs in culturally mediated activities. So in learning mathematics, it is the mediated activities. It actually consists of the sign and the tool. The sign and the tool adjust human behavior or mathematics activities differently. The sign is internal activity, targeting and master oneself. It is oriented inward toward the self-regulation, and the tool is oriented outward, aiming at mastering nature. The combination of the sign and the tool can produce higher level human activities or mathematics learning activities. The development here persists is not a circle. It is actually passing through the same point at each revolution while advancing to a higher level. There are three serious positions about learning and development. The first one is development is independent of learning. Development is the prerequisite of learning. If a student's mental function has not matured to the extent that he is capable of learning the subject, no instruction will prove useful. The second position, teaching is a development, or learning is development. Learning is completely inseparable and blended with development. The third position overcomes the extremes of the first two positions and simply combine the learning and the development. It states learning and development coincide at all times. Vygotsky rejects all the three positions. He proposed the zone of proximal development. And he believed the learning and development are interrelated. There are actually two development levels. One is the actual development level. That is the student solve mathematics problem independently. The second level is the zone of the proximal development. It is the potential that students can achieve under the guidance of teacher or their peers. Learning mathematics, the goal here is to identify the zone of proximal development so that the teacher can help students go from point A to point B. So far, I talked about culture and cognition development connects to the culture-relevant pedagogy. The culture-relevant pedagogy promotes practices, collectiveness, and interconnectedness that has the roots for decolonized mathematics. Decolonized mathematics employing components of belonging, mastering, independence, and generosity. These four attributes actually connected to the learning process for mathematics. So when you teach mathematics concept or technique, we actually start with motivation. We motivate students by introducing why this topic is discussed. And then in master phase, we give them the space, we instruct them the specific questions, give them examples. And then we give students exercise that can independently to complete. Finally, we give students the projects so that students can synthesize the concept and the techniques in mathematics learning process. Dr. C, the founder of Mathematics, Culture and Environment Academy at University of Dover, she is actually the first indigenous woman receiving PhD in physics. She and her colleagues built two projects using the belonging, mastering, independence, and generosity, and also incorporate indigenous knowledge into mathematics education. The first project that have built a drum, students are asked how much materials are needed in building a drum. In this example, they also invite the elders, so students can have the concrete ideas, what is involved for calculating the area, the volume, and even the abstract mathematics natural number pi. The second project I did is the integer logics. It is a pre-college programs targeting for integer students using integers-based knowledge and use everyday life students are familiar with into mathematics education. Another decolonizing mathematics project is done by Dr. Raju for decolonized calculus learning. He demonstrated calculus can be learned in 5 days instead of the whole semester. He also promotes eliminating the notation of the integral and the derivatives in calculus. His method is demonstrated with 8 groups of students across 5 universities in India, Malaysia, and Iran. The last project for decolonizing mathematics is done by Professor Betty. They actually use the bead project. Students are asked to construct the circular beaded mandalas where students can explore the patterns, proportions, relations, and simple algebra. In conclusion, this presentation takes a cultural historical approach to explore learning and cognition in general and implications for culturally relevant mathematics education in specific. The purpose is to seek a deeper understanding of how culture and mind intermingled and how to draw culturally relevant pedagogy to effectively teaching mathematics. Mathematics is a discipline filled with emotions, design, and sense of belonging. Learning mathematics is situated in the wave of teacher-student relationships, culture, school community relationships, and the curriculum. Mathematics can be decolonized. We just need to connect mathematics with culture-relevant community practices to deepen students' understanding of mathematics in a meaningful and practical way. That concludes my presentation. Thank you.